For years, generating an image with AI felt like pulling a lever on a slot machine. You'd type a prompt, wait for the processing bar, and hope the result resembled your original idea. The results were notoriously unpredictable. Human hands would render with 6 or 7 fingers, text on signs appeared as unreadable gibberish, and the model would invent an entirely new person if you tried to view the same subject from a different angle. This randomness made the technology difficult to use for commercial artists and designers. Professional workflows rely on exact brand consistency and precise art direction, requirements that are difficult to meet when a tool constantly guesses at the details. Google DeepMind developed Nano to move the technology toward a more structured design process. Nano is built on the Gemini 3 Pro architecture, a multimodal artificial intelligence model designed to reason across text, images, and code. By focusing engineering on precision over probability, the goal is to shift the user's role from a prompt engineer hoping for a lucky result to a director commanding a digital environment. Nano starts by treating the digital canvas as a space governed by real-world logic. The model uses its reasoning capabilities to understand not just what objects look like, but how they relate to actual, factual information. This diagram shows how the model pulls in data from Google Search. If you ask for a botanical breakdown of a plant or a step-by-step recipe, the system retrieves accurate facts and automatically formats them into a structured visual layout. Because the system understands language context, it can generate highly legible text directly inside the image. You can specify overlapping 3D block letters with textures like a retro halftone dot pattern, and the spelling remains accurate. A halftone pattern is a printing technique that uses dots of varying sizes and spacing to simulate smooth gradients and colors. That linguistic understanding extends to translation. You can instruct the model to translate that same poster into Korean, and it will rewrite the characters while keeping the precise 3D layering and screen-printed textures intact. This grounding in language and facts allows the generator to render complex data as accurately as it renders pixels. In the past, generating the consistent cast of characters for a storyboard or an ad campaign required heavy manual editing. If you asked an AI to generate the same subject twice, their facial features and clothing would often drift between frames. Nano addresses this with consistency by design. The model can take up to 14 distinct input images and render them into a single, cohesive cinematic medium shot without losing their individual characteristics. This applies to photorealistic subjects as well. You can lock in the exact facial identities and wardrobes of up to 5 distinct human models, placing them in a high-fashion desert shoot where the lighting and physical proportions remain consistent. Maintaining these rigid variables across multiple generations is a necessary step for narrative storytelling and large-scale commercial brand design. Once the base image is set, the workflow moves into localized editing. Instead of generating a completely new image, you use natural language to alter specific regions of the canvas, while the rest of the composition stays frozen. You can isolate the environment and instruct the system to shift the time of day. A bright afternoon becomes a dimly lit nighttime scene, complete with harsh, directional moonlight and accurate shadow casting on the subjects. You can also isolate individual elements to manipulate cinematic properties. You can shift the depth of field to blur the background, or apply intense chiaroscuro lighting directly to a character's face. Chiaroscuro is an artistic technique that uses strong, dramatic contrasts between light and dark to create a sense of three-dimensional volume. If the output needs to move from a widescreen monitor to a mobile feed, the aspect ratio can be adapted to a 1:1 square. The model resizes the environment, preserving the essential details of the composition rather than simply cropping the edges. These specific controls replicate the physical adjustments you would make on a practical film set, giving the user direct authority over the final frame. With 4K resolution and improved textures, the visual markers that once identified a synthetic image, like warped fingers or blurred edges, are becoming increasingly difficult to spot. Because of this, it is necessary to build an invisible layer of proof directly into synthetic media. Without a verifiable way to trace an image's origin, establishing the history of a digital file becomes more complex. Google's solution to this is SynthID. SynthID is a digital watermarking tool developed by Google DeepMind that identifies AI-generated content by embedding a cryptographic signature into the file. SynthID embeds a hidden cryptographic pattern directly into the pixel structure through subtle color shifts undetectable by human eyes. This durable watermark survives heavy editing, cropping, and compression. Upload any image to the Gemini app to scan this signature and confirm its origin. As synthetic media achieves higher fidelity, the utility of AI depends on the engineering used to verify its origin, as much as the code used to create its visuals.